This video goes with Unit 6, Chemical Equations and Reactions. The essential questions are: what is a synthesis reaction, what is a decomposition reaction, and how can you determine what type of chemical reaction is happening? So the first type of chemical reaction is a synthesis, and synthesis means to make something. So we have two substances combining to make a single compound. So the general formula for this is you have an element, two different elements, A and B, and they combine to make a compound on the other side. So here we have two dance partners standing by themselves, and then they start dancing. For instance, magnesium and nitrogen, they're two separate things all by themselves, and we can make magnesium nitride. Okay, so here's a picture of that. I'm going to go ahead and balance that. I needed 3 magnesium on the other side. Here's another example. Aluminum and fluorine makes aluminum fluoride. Okay, again, I want to balance this so that I have the same number on each side and follow the law of conservation of mass. But if you look at these, how you can tell is that there's only one thing on the right-hand side. Those are called synthesis. Okay, so here's another example. I have potassium, I have chlorine separate, and then it makes potassium chloride. Again, I only have one thing on the right side, so it gives me a clue that it's going to be synthesis. Okay, here's another couple of examples. Sodium metal combines with oxygen gas to make sodium oxide. So I need to do my crossovers there. Okay, and I have O2 because it's part of Brinkelhoff. Okay, so they were separate, and I crossed over, and now I'm going to balance. Okay, I have 2 oxygens on the left, so I need 2 on the right, but that gives me 4 sodium, so I need to fix that also. Okay, hydrogen gas combines with oxygen gas. So again, those are both part of Brinkelhoff. Okay, so they have H2 and O2, and that's going to make water vapor. Okay, so now I have water. So again, on both of these, you can see you only have one thing on the right-hand side, and that tells me that it's going to be a synthesis. So now I want to go ahead and balance this. I have 2 O's on the left, so I need 2 on the right. And that gives me 4 H's, so I need to adjust on the left for that. Okay, so here's an example of that in a balloon and having the candle, and then water vapor is released because they combine. Okay, the opposite of that is decomposition. It's when something breaks down. So the general formula is if you have the compound, it breaks into the elements. So decomposition is like a breakup. You have a couple there, and then they split apart. Okay, so this is an example of a type of decomposition. This is electrolysis. So and it's adding electricity to break salt apart. So if you have NaCl combined and you add this electricity, it's going to separate into Na and Cl2. So I'm going to go ahead and balance that out. I have 2 Cls on the left, or on the right, I'm sorry, so I need 2 on the left, and that changes my sodiums also. Okay, but what I can see here is that I start out with one thing on the left and then it breaks apart, and that helps me identify that it's decomposition. Okay, so here's another example. I have mercury oxide, and it's breaking into mercury and oxygen. Okay, so here's HGO. I only have one thing on the left, so right away that tells me it's decomposition. I'm adding some heat, and so that becomes mercury and oxygen separately. I'm going to balance that. I have 2 oxygens on the right, so I need 2 on the left, and that changes my mercury. So if we practice this a little bit, Mg plus O2 makes MgO. I see 1 on the right, that tells me synthesis. On number 2, ammonium nitrate, and it's being broken apart. I have 1 thing on the left, that tells me decomp. Number 3, I have 1 on the right, synthesis. Number 4, 1 on the left, decomposition. So it's as simple as that when you're trying to identify if it's synthesis or decomposition. Just look for if there's 1 on the left or 1 on the right.